Well, hello. Today we're going to do a lab related to Archimedes' principle, and we're going to show what Archimedes tried to suggest, is that the buoyant force upward on an object equals the weight of the water that's kind of pushed off to the side, that's moved out of the way, that an object is going to displace. So today we are going to use that for a couple items. First of that is going to be this. This happens to be a 500 gram mass, okay? And we can verify this. If I put this on this scale right here, we can verify that, yes, indeed, it reads 500 grams. Okay, so that is this 500 gram mass. Now, this object, it's a 500 gram mass, which on your sheet is 0.500 kilograms. And the acceleration due to gravity is 9.8 meters per second squared. So this object has a weight of 4.9 newtons, because 0.5 times 9.8 is going to be 4.9. So it has a weight of 4.9 newtons pushing down. The buoyant force is going to somewhat offset this weight, as we are going to see. So I've done step number 2. I've confirmed that this indeed has a mass of 500 grams. Okay, it's off a little bit here, not too much, pretty close. Okay. And I have here, and I'm going to lower the screen just a little bit, what's called an overflow container. This container right here, okay? And I have this overflow container. It's filled up with water all the way up to this nozzle, okay? So if I put my finger in here, water's going to start spilling out of this nozzle right here. And what I'm going to do here is I am going to take a graduated cylinder, and I'm going to set it underneath this nozzle here, and I'm going to lower this into this overflow container. Right now, my graduated cylinder is catching water that is spilling out of this overflow container. Okay? Letting that continue to drop out there. And if you look at what my scale now reads, if I read this carefully, you're going to see that my scale now reads about, probably about 445 grams. Okay, so that is going to be what my answer is on number 6. So my answer number 7 should be pretty easy to answer, okay? It's going to be what it reads afterwards. It's lost about 55 grams of mass. So I'm going to reverse question number 8 with question number 4 here. I'm going to mass this, says beaker, but I'm going to mass this graduated cylinder here. And you are going to read what this mass is. So I'm giving you the answer now to number 8. And, whoops, let me turn this on here. It went dead on me. So I'm going to mass this now. And it reads 157.9 grams. I don't know if you can see that. That's what it reads. So that's my answer number 8. I'm going to work backwards and empty it out and figure out what the mass is. This will be my answer to number 4. So I'm going to pour this out. I'm going to mass it again. It now reads 102.7 grams. That is my answer to number 4. Okay. Now this isn't exact here, but it's pretty close. You have enough data now to answer questions 1 through 11. Do that, and then we'll return for part 2. It starts at question number 12, which has a significant gap in between 11 and 12, but we'll meet you at question 12. Right now, finish 1 through 11. So the first one should have shown that the buoyant force equals the weight of the water displaced. The mass weighs the same amount less that is equal to the water that was pushed off to the side. We're going to do the same thing now with an object that doesn't sink, but rather that it floats. Okay? Now, if it floats, that means that the weight pushing down on this block equals the buoyant force acting up, because the net force would be 0. So what we're going to do here is number 12, we're going to figure out what the mass is of this block just by itself. Okay? So it reads here that this mass is 62.9 grams. That's going to go into answer number 12. Now, we're going to record what this flask is by itself, this graduated cylinder, I should say, number 17. The mass of this by itself is 102.6. It read 102.7 before. That's my answer to number 17. Okay? I am going to, I'm sorry. That is actually my answer to number 4 again. I'm now going to place this block to in here, and again it's going to displace some water, but this block isn't going to get entirely submerged. So I'm going to capture some water in this graduated cylinder that spills out as I put this in. So I'm letting that go in. I'm capturing that water that is spilling out. And I'm almost there. So now I'm going to remass this. I'm going to give you the answer to number 17. And number 17 reads 155.3 grams. 155.3 grams is my answer to number 17. If I subtract number 4 from number 17, I should get the mass of the water by itself. And then that should tell me what the mass of this wood block is. Okay? Now, think about it. If I push this block down, it's going to submerge more water, but almost immediately it's going to pop back up to the surface, because if I push this down, it's going to displace more water. The buoyant force is going to be greater than the weight, and so it's going to pop right back up again. So this is Archimedes' principle. You should have enough information to get through number 21.